Welcome to the second half of the Chapter 17 Water Resources lecture. We begin today on the page in your notes with describe how water moves from the surface to the subsurface at the top of the page. So, how does water move between the surface and the subsurface? We have precipitation, snowmelt, and surface water that can soak into the subsurface and become groundwater. We call this infiltration. The water table is generally below the surface, providing the unsaturated zone into which water can seep. Where the water table intersects with the surface, water can flow out into springs, lakes, or rivers. So as the water infiltrates from the surface down through the ground, it passes through the unsaturated zone, it hits the water table, and below that is the saturated zone. So once it hits the saturated zone, it becomes part of the rest of the groundwater, and then it can flow downhill. And remember, the water table is just like the surface, except slightly more subdued. And so again, where the water table intersects with the surface and water flows out, you can get springs. It can flow into lakes or into rivers. How are lakes and wetlands related to groundwater? So let's observe this image and how the water table relates to these lakes and wetlands. So we can see the water table is the blue area below the surface with a white line on the top. And how do you think you could determine which of these settings a lake would be in? So here are settings. We have perched above the water table. We have the water table intersects with the surface. We have wetlands at the water table or perched. We have on a topographic bench, and we have on a valley bottom. So again, how do you think you could determine which of these settings a lake would be in? So there are a few different ways. We want to determine elevation of the water table. We can do that through drilling. We can see whether a lake was losing or gaining water by modeling inflow, outflow, and evaporation. So measuring how does the water level change? How much is it losing, and is it actually gaining? Or we can compare the chemistry of the lake water with runoff and with groundwater. So in those three ways, we can see how all of these are connected. If we have flow between them, or if they are isolated. How do rivers interact with the water table? Okay, so we've got two different types of rivers we're going to be discussing here. Rivers are streams. So in the first one, we're looking at how each river relates to the water table and whether water flows from the river into groundwater or from groundwater to the river. So that's what we want to be looking for. Which way is the water flowing? Into the river or out of the river? And how do you think you could determine which situation was occurring? So think about that. How would you decide, if you're here on the surface, what could you do if you're looking at the stream to figure out whether water's flowing into the river from groundwater or flowing from the river out into groundwater? So it's similar to our previous answer. We can determine the elevation of the water table by drilling. We can see whether a lake was losing or gaining by modeling inflow, outflow, and evaporation. So in this case, it's not a lake, but a river. But it's the same idea. We're taking a look at inflow, how much water is going in, outflow, how much water is going out, and how much is evaporating. And then the last one, compare the chemistry of the river with runoff and with groundwater to see which way the water's moving. So a river lower than the water table is going to be gaining water from inflow of groundwater. Okay, so in this top image you can see the river is lower than the water table, and so the water table is flowing downhill into the river. Okay, in the bottom image the river is higher than the water table, so the river is actually losing water to groundwater. So you can see that it's flowing downhill out of the river and into groundwater. You get a mound of groundwater forming below the river due to outflow of the river water into groundwater. So this top river here, this situation where the river is gaining water from the surrounding groundwater, we call this a gaining stream or a gaining river. And in the bottom image where the river is losing water to groundwater, we call that a losing stream or a losing river. On to the next page of notes. How do we study groundwater? So the first way is through field studies. So they're looking for types of rock and sediment in the area, so that they can estimate the overall permeability. They want to know how well can water flow through what types of rocks and sediment are there. They also want to look for the abundance and orientation of fractures, because that's going to tell them about permeability as well. They want to know about the orientation of layers, because sometimes water will flow along in between layers, so if they're tilting, they might tend to flow along that tilt. Presence or absence of cavities, and characteristics of the material such as the class size and degree of sorting. So that gets back to what we talked about last week when we were talking about porosity and permeability. If you have a poorly sorted rock, meaning you have all different sizes of sediment in it, then that's going to affect your permeability greatly. All right, the next one is geophysical studies. So the types of studies that they do within that category are gravity surveys to determine the depth to bedrock, because as you can see where the line is pointing here below, we've got this gray hard rock or bedrock extending down below the sediment, and that acts as a boundary. That can act as almost like in a bathtub, right? The walls of your tub extend down below the water level. That's what's going on here with the bedrock. So you want to know what the depth to bedrock is so that you can figure out what so you can figure out how deep that aquifer can go. Seismic studies to determine geometry of layers, units, and faults. And lastly, electrical surveys to determine the location of the water table and the geometry of the units. Okay, the last step is going to be drilling, because this is usually the most expensive step. So the purpose of drilling is to describe the sequence of materials versus depth. What kind of rocks are there? How deep are they drilling? How deep is it to bedrock? How deep is it to the water table? That sort of thing. The characteristics of the materials, including class size, the abundance and orientation of fractures. Sometimes they lower special video cameras down into the drill hole to observe what exactly is below the surface. And geophysical surveys done within a drill hole, such as how much radioactivity each layer gives off, that kind of thing. And once the well is drilled, then they do pumping tests, also called an aquifer test, and this is conducted to evaluate an aquifer by stimulating the aquifer through constant pumping and observing the aquifer's response or drawdown in observational wells. So this can give the scientists an idea of how much water they will be able to pull out of that well. Lastly, measuring discharge, losses, gains, and water quality in the surface water and in groundwater will help you decide, is this water viable, does it need to be treated, that sort of thing. How do we depict the water table? So in this image here, the numbers show elevations of the water table. What is the pattern that you see? Examine the map and try and find a pattern. Which way do you think groundwater would flow? Okay, so what I look for in this image is where are my highest numbers and where are my lowest numbers, because I know each number represents the elevation of the water table, and water always flows from higher elevation to lower elevation. So where are our highest elevations? Okay, I can see in the upper right hand corner I've got at a 150 and then 140 to the left of that, and it's getting lower as we move down or south on our map. So what makes it easier is if you draw in the elevation contours. The water table is at the same elevation along each contour, just like a topographic map, but this is dealing with the water table. And in this case, the blue arrows are showing us the flow. We visualize the system to compare the water table to other features such as farms with wells that pump high volumes, and this is in a different area. But looking at this image here on the right, how would you expect water to flow? Okay, we can see our contour lines are going on this image left to right, or right to left. It's at an angle. And so groundwater always flows perpendicular to the contour lines. So if we've got our lines going left to right, then we're going to have our flow go, in this case, from top to bottom, because at the top we're at 800 and at the bottom we're at 300.